Here is a numerical type question. Work through the numbers carefully. Let us solve it step by step. Let us first understand the key concept here. Geometrical, cis-trans isomerism in cycloalkanes arises when substituents on the ring can be placed either above, up, or below, down, the plane of the ring. For a trisubstituted cyclohexane like 1, 3, 5 trimethylcyclohexane, we assign each methyl group an up, U, or down, D, orientation relative to the ring plane. Moving on to the next step. List all possible up-down combinations for 3 methyl groups at C1, C3, C5. The possible arrangements are: all up UUU, 2 up, 1 down, UUD, UDU, DUU. These 3 are related by the symmetry of the 1, 3, 5 positions. 1 up, 2 down, UDD, DUD, DDU. These 3 are related by the symmetry. All down, DDD. Moving on to the next step. Apply the symmetry of the molecule. Because the 1, 3, 5 trimethylcyclohexane has a C3 rotation axis, the 3 positions are equivalent, UUU and DDD are identical, one is just the mirror flip of the other and they superimpose, they are the same compound, all CIS or all-trans relative arrangement. Similarly, UUD, UDU, and DUU are all the same compound by rotation and UDD, DUD, DDU are all the same compound by rotation. And for the final step, check if the 2 distinct arrangements are mirror images, enantiomers, or identical. Arrangement 1, all 3 methyls on the same face, UUU is equal to DDD. This molecule has a plane of symmetry and is achiral, meso-like. It is the all-CIS isomer, each pair is CIS to each other CIS 1, 3, 5 trimethylcyclohexane. Arrangement 2, 2 methyls on one face, one on the other, UUD type. This gives the 1, 3 CIS, 1, 5 CIS, 3, 5 trans pattern, or equivalent. This molecule also has a plane of symmetry and is achiral. Count distinct geometrical isomers. The 2 distinct configurations are: 1. All 3 methyls on the same side, all CIS 1 isomer. 2. 2 methyls on one side, one on the other, 1 isomer. Thus there are 2 theoretical geometrical isomers of 1, 3, 5 trimethylcyclohexane. Why not more? The C3V symmetry of the molecule reduces all 8 formal combinations to only 2 distinct structures. Neither is chiral, so there are no enantiomeric pairs to add. Therefore, the correct answer is 2. Therefore, the correct answer is 2.